Hello everyone. We are continuing with the topic called percentage. Some of the basic concepts have already been covered in my first video, whose link is given in the description below. Today we are looking at two important concepts very useful in quantitative aptitude of any competitive exam. The first concept, given two numbers, say x and y, it's about finding x is what percentage of y, and the second one, y is what percentage of x. Let me illustrate the concept with a numerical example. Supposing you wrote an exam with maximum marks being say 50 and you had a score of say 30, then how do you find out your percentage score? See, 30 out of 50 multiplied by 100. This is something most people are quite familiar with. So basically, this gives you 30 as what percentage of 50. And this on simplification, 60. And don't put percentage sign here. If the question is about finding your percentage score, it is understood that this score you had out of 100 as equivalent to 30 out of 50. Basically, this is the point I'm trying to say. 60 percentage not equal to 60. It's a common error most people commit when dealing with percentage problems. In this case, if you put x here and y here, x is what percentage of y? Basically, x divided by y into 100. It's a simple idea. Now let me look at the next one. Y is what percentage of x? Let me look at another example. You wrote an exam and you had a score of 30 marks. I'm not talking about the maximum marks in this case. And you are writing this exam second time and there was an improvement to 50 marks. If you are asked to find out the second score or the new score, which is 50, as what percentage of the old score, what do? You take 50 divided by 30 into 100. This on simplification, 166, 2 by 3. Here this is y and this is x. So basically y is what percentage of x? That's the meaning of the question. So it will be just y divided by x multiplied by 100. So to find out one number as what percentage of the other, the first number divided by the second number multiplied by 100. So this is the first one. This is the second one. Now let's look at the second concept. It's basically about comparing two numbers or two quantities in percentage terms. For example, given two numbers x and y, where x is greater than y, there are two questions normally in comparison. The first one, x is what percentage more than y? And the second question, y is what percentage? See, here x is assumed to be greater than y. So in the second comparison, y is what percentage? Less than x. These are the two questions we try to define in the second concept. Again, let me choose x as 50 and y as 30. See, I'm choosing numerical examples to illustrate this point because the concept will get clearer with the numerical examples rather than variables. So the first question will be 50 is what percentage more than 30? X is taken to be 50, y is taken to be 30. So the question will be this: 50 is what percentage more than 30? Now the meaning of this question, you know the absolute difference between 50 and 30. Rather, 50 is more than 30 by 20 in absolute terms. But when converted into percentage, it will not be 20. It will be something else, which is what we are going to find out here. See, many people think 50 is more than 30 by 20%, which is wrong. Whereas 50 is more than 30 by this absolute number 20. And the meaning of this question is that 20, which is the absolute difference between 50 and 30, is what percentage of 30? See, 50 is more than 30 by 20. And that 20 is what percentage of the second number, 30. We have already defined how to find out one number as a percentage of the other. So 20 is what percentage of 30? 20 divided by 30 multiplied by 100. And this comes to 66, 2 over 3. Again, like I said, comparison can be done in two ways. If 50 is more than 30, 30 is definitely less than 50. And that comparison goes like this. 30 is what percentage less than 50? That will be, again, like we did before, 30 is less than 50 by the same number 20. In absolute terms, both are the same. 50 more than 30 and 30 less than 50. But in percentage terms, they are different. And that 20, which is the absolute difference, as a percentage of the second number, 50, multiplied by 100. This on simplifying, you get 40. So you can observe a couple of things here. One, 50 is more than 30 by 66, 2 over 3 percentage, whereas 30 less than 50 by 40 percentage. The figures are different. This is a common error most people make. Most people think both of these questions will have the same answer, which it is not. So please make note of it. Given two numbers, when you compare as one more than the other and the other one less than the first one, you're going to get two different percentage figures like we have here. And they are never going to be the same. The second confusion most seem to have, see, if you compare these two numbers, 20 divided by 30 into 100, 20 divided by 50 into 100. There is difference only in these two denominators. Can you see? 30 and 50. Here you write 30, here you write 50. And most people are confused about what to be written where. I'll give you a simple tip using which you will always get it right. See, look at this. The denominator, see, there is no difference in the other two numbers, 20 and 20, 100 and 100. But there is difference only here. To remove the confusion of which number to be written here in the denominator, you may go by this simple rule. We write the number that comes after the word than. You can see that. See, more than 30. 30 comes after that, so 30 is written here. In the second one, look at this. Less than 50. So 50 comes after the word than. That 50 is written here. So in the denominator, we write the number coming after the word than. If you memorize this, you will never make any mistake in finding the percentage comparison of two numbers. So to summarize the whole thing, we will use variables in place of numbers in these examples. The fundamental question was this: X is what percentage more than Y? To find out that, you take the absolute difference between X and Y, then multiply it by 100. Then what variable to write in the denominator? Look at this. Y comes after the word than. So Y is written here. Got it? Now the second one. Here Y is what percentage less than X. Again, you take the absolute difference multiplied by 100. And in the denominator, we write the number coming after the word than, less than X. X comes after the word than, and that X is written here. I hope you won't make any mistake when comparing two numbers in percentage terms. The first point to note is the values are different. And the second thing, always write the number coming after the word than in the denominator. Numerator, there is no confusion. To summarize the whole thing in a simple formula, let me put it this way. Percentage increase or decrease. See, in the first case here it is increase. X is more than. In the second case, Y is less. So decrease. In both the cases, you take absolute difference multiplied by 100, and in the denominator you write the number coming after the word than. And that number is called base figure. See, in any comparison, there is a number to which comparison is made. That is what this number is all about. The number coming after that. And that is the number. So in a formula, we write it like this: absolute difference multiplied by 100 divided by base figure. Let us look at an example using the concept discussed here. You wrote an exam and had a score of, say, 60 marks. The same exam you wrote again, and second time you had a score of, say, 80 marks. Certainly there is an improvement. And how much is the improvement in percentage terms? Rather, we are comparing the new score, which is 80, to the previous score of 60. Rather, 80 is what percentage more than 60. So what do? You first take the absolute difference, which is 80 minus 60. Since 80 is compared to 60, 60 will go down in the denominator. See, 80 is what percentage more than 60. So 60 comes after the word than. Then multiplied by 100. On further simplifying, you get this. So you had an improvement of 33 and 1 by 3 percentage compared to the previous score you had. Now let's work out a few simple problems to get the concepts clearer. A's weight is 25% more than that of B. By what percentage is the weight of B less than that of A? There are a couple of different ways to solve this problem. I'll take you through the shortest approach. See, the problem doesn't talk about the actual weights of these two persons, A and B. They say A's weight is 25% more than B. And what is B's weight? We don't know. Finally, the answer is again a percentage calculation. So in such problems, whatever is not given, see B's weight we don't know, we will take it as 100. If you assume B's weight as 100, the problem says A's weight is 25% more than that. See, 25% more than 100 is 125. See, 25% of 100 is 25. Just add that 25 to 100, you get 125. And the question is, by what percentage is B's weight, that is 100, less than that of A, which implies what? 100 is what percentage less than 125. How do you find out this? You take the absolute difference. 125 minus 100 divided by, see, 100 is compared to 125. So the number to which comparison is made is 125. That's one way of looking at it. Another way, to make it easier, 100 is what percentage less than 125. 125 comes after the word than. So you write 125. You write the number coming after the word than in the denominator, multiplied by 100 equals 25 divided by 125 multiplied by 100. 25 goes 5 times, 5 goes 20 times. So 20. Here it doesn't matter what value we choose for the unknown B. I have taken it 100 because 100 is in most cases the best possible choice to ease the calculation. In fact, we can choose any number for B here, or for that matter even a variable, and complicate the solution. So to help you understand why this is a better approach, let me choose variables for B. Let me take B as the weight of this person B. Then, since A is 25% more than B, how do you increase a number by 25%? This is what you do to increase B by 25%. Write B first, take 25% of B, then add to that. Simplify, this goes 4 times. So you get B divided by 4 equals 5B divided by 4. So A's weight is this one. Let me write that here. 5B over 4. Now the question is, B is what percentage less than 5B divided by 4? So like we did before, take the absolute difference between these two. Since B is compared to this, that number we write in the denominator multiplied by 100. This will be the percentage by which B's weight is less than that of A. Let's simplify. B is common. Take B outside. 5 divided by 4 minus 1 multiplied by 100. Here you can see this B. Let me write it first and then write 5 divided by 4. These two will cancel out. 5 divided by 4 minus 1 on simplification. You will get 1 by 4. Then divided by 5 by 4 multiplied by 100. These two will cancel out. You have 100 divided by 5 equals 20. This is the same as this. See, look at the way things are getting complicated here, and we need more time to solve this problem taking b as a variable. In fact, you can use any number, any weird odd number. You can put even, say, for example, what to say, 30 for b. Only thing is that calculations will get harder, and finally you will get to the same answer. So it doesn't matter what value you give to the unknowns in the percentage problems, provided of course the question is about finding another percentage like in this problem. So in my opinion, whatever is not given, you choose in most cases 100. In some other cases, you will vary. I will work out another problem showing where you can slightly change the assumption of whatever is not given in a problem. Let's look at the second problem. The second question is this. A's score in an exam is 25% more than that of B, and B's score is 20% more than that of C. By what percentage is A score more than that of C? We have three people here. Let me write that first. A, B, C. Now A score is related to B and B score is related to C. But finally, what is C score? We don't know. So like we did before, choose this as 100. Now you will begin with B here. B score is said to be 20% more than that of C. Obviously, B score will be 120. And A score is said to be 25% more than 120. Rather, B score. How do you find out that? See, A's score will be 120 plus you're increasing that by 25% of 120. This goes 4 times and this goes 30 times. So 120 plus 30, 150. Let me write that 150 here. So we got all the scores. Now the question is what? We are comparing A score to C score. See, the beauty of starting with 100 is this. You don't need to finally work out the percentage again, because if you begin with 100 and when you compare something else to 100, the absolute difference, look at the absolute difference between A and C, that is 50. And that will be the percentage increase also. This is not true of any other number. If the original number is 100, and if you're looking at a number above or below 100, the absolute difference will be the same as the percentage increase or decrease. See, using the definition, how do you arrive at 50? You take the absolute difference. Can you see this? Then what do? 150 is compared to C. So C score will be written in the denominator. Rather, 150 is what percentage more than C score, which is 100. The number coming after than is 100. I'm writing it in the denominator. You simplify this, you will get 50. Can you see that? You don't need to waste time doing this. That's the beauty of starting anything not given in a problem as 100. In fact, any number is okay here, but when choosing 100, things will get even shorter than otherwise. If you want to complicate this problem, you can choose this as a variable and proceed further like we did before. But try to avoid using variables if the question is about finding a percentage like we have here. There is one more observation you can make in this problem. See, C is increased by 20%, then it is again increased by 25%. So most people tend to think that there are two increases. One is 20, the other is 25, as you can see in the problem. And this sum is 45. And people tend to think that A will be 45% more than C, which it is not. As you can see, 50 is the correct one. It's a common error people make in percentage calculations. So please note this point carefully and try to use in percentage calculations. I'll show you one more problem to highlight this common error being made by people in dealing with percentage problems. Supposing you have a product whose price is increased twice successively by 10%, the new price you get will be how much percentage more than the original price? Most people think it is 20%. Because when I say something is raised by 10% twice successively, they take it as 10 plus 10. But this 20% is wrong. Then what is the correct percentage increase? We don't know the original price. You take the original price as 100. When you increase it by, say, 10%, after the first increase, the price will be 110. And the second time, when you increase 10%, that's from this level. See, what is 10% of 110? That is 11. Can you see that? And that will be added to this price. So what do you get? 121. So after two increases, 100 becomes 121. Like I said, the absolute difference is 21, which is also the percentage increase. So 21% is the actual increase or the effective increase in the price of a product when its price is raised twice or rather two times successively by 10%. Now there is another question. Supposing the price of a product is increased by 20%, then you are reducing its price by 20%. So there are two changes. First, the price is raised by 20%, then the price is again reduced by 20%. The new price you get, will it be more or less than the original price, or will it be the same as the original price? Most people tend to think the price will not change. When you increase something by a certain percentage and again reduce it by the same percentage. But that's wrong. They think it is a 0% change. There will be change in the price, and the new price you get will always be less than the original price of whatever. If anything is increased by a certain percentage and again reduced by the same percentage, the new value of the quantity will be invariably less than the original one. I'll show you that here. Let me take 100 as the original price or whatever of something. You are raising it by 20%. So that will become 120. Then what are you doing? This is reduced by 20%. How do you reduce 120 by 20%? 120 minus 20% of 120. And this is equal to 120 minus 24 equals 96. So what do you observe? You started here as the original value of something. After two changes, one increase followed by a decrease with the same percentage, that finally goes to this level. So this is less than the original value. And how do you calculate the percentage change? Take the absolute difference. 96 is what percentage? Less than 100. Than 100. So 100 written here. Calculate that. You will get 4. So the main observation you can make is that when something is increased and decreased by the same percentage, the new value you get will always be less than the original value. In fact, there is a shorter way to get to this number 4. See, here it was increased by 20, again decreased by 20. So you write 20 square divided by 100. This is the answer. This is the shorter way to arrive at the answer. This is what? 20 multiplied by 20, 100. What do you see? 4. There is a simple formula. In fact, if something is increased by X percentage, again reduced by X percentage, the new value you get will always be less than the original value, and the reduction in percentage will be X squared by 100. This formula may be used in problems of this kind. Supposing something was increased by 30% and again reduced by 30%, the effective reduction in percentage will be 30 squared by 100, which is, on simplification, 9. Now let's move to the third problem. The third problem is this. If the length of a rectangle is increased by 20% and the breadth reduced by 25%, what would be the change in the area of the rectangle? As we know, area equals length multiplied by breadth. L is the length, B is the breadth. This is a simple formula you are all quite familiar with. Now we don't know the original breadth and length and hence the area of the rectangle. So what do? See, here the problem is what would be the change in the area of the rectangle? Of course, this should be in percentage terms. Because unless you know the original area, rather the length and breadth, you cannot find a change in the area in absolute numbers. So what I meant to say is, since the question is again a percentage thing, whatever is not given, length and breadth I mean, you can choose whatever number you want. Usually we go for 100, but there is a slight difficulty. 100 is fine, but to make it easier, let me go for L as 1 and B also as 1. So that area will be 1. If you go for 100, no issue. Here you will be writing 100. Here you will be writing 100. And on the left side, you will be getting 1 followed by 4 zeros. There is a lot of time getting wasted writing zeros. That's all. Usually, the assumption is between 100 and 1. And there are cases when you will even go for some other numbers. I'll show you that in this problem. Okay, let's go with this. This is a pretty short approach. Now, what does it say? Length increased by 20%. Length taken to be 1, increased by 20% means you take 20% of 1. This is 1 divided by 5. So you get 1 plus 1 by 5. On simplifying, you get 6 over 5. So this is the new length. What about the new breadth? Breadth is reduced by 25%. So 1 minus 25% of 1, which is 1 minus 1 over 4. On simplifying, 3 divided by 4. So this is the new breadth, this is the new length. So the new area will be 6 divided by 5 multiplied by 3 divided by 4. 3, 2, 9 divided by 10. Okay, let me convert this into decimal. There's a reason for that. So the new area is 0.9. Original area was what? 1. You can see that here. New area after these two changes, 0.9. We are actually finding the change in the area of the rectangle in percentage terms. So 1 is getting reduced to 0.9. Here again, you don't need to waste time converting that into percentage. If 1 becomes 0.9, the percentage reduction in area is just 10%. If you are not convinced about this, I'll show you. See, 0.9 is what percentage smaller than 1. Take the absolute difference divided by 1 multiplied by 100. This is equal to 0.1 100 divided by 1. This is what? 10. And you get 10. See, 1 becoming 0.9, 10%. 1 becoming 0.8, 20%. 1 becoming 0.75, 25%. That's all. So these are the advantages of choosing 1 or 100 as numbers not specified in a problem, because finally you don't have to waste time working out the percentage change. Now let me approach this problem slightly differently. There, what I am going to do, instead of choosing 1 and 1, see, A is L times B. Let's take L as 25 and B as 4. Any numbers you can choose, irrespective of what numbers you choose, finally you get the same answer. So I'm choosing L as 25 and B as 4. So that area will be what? 100. Make the changes given in the problem. Length is increased by 20%. That means this will get increased by what? See, how do you increase 25 by 20% of 25? This is what you do to increase this number by 20%. This on simplification, you will get 30. I'm not simplifying. You do that. Similarly, breadth taken to be 4 is reduced by 25%. 25% of itself. That's the meaning. This on simplifying, you will get 3. You simplify that, I'm leaving it to you. So 30 multiplied by 3, 90. Now look at that. Originally area was 100. After these two changes, got reduced to 90. So the percentage reduction is 10. See, like I said, if the original number is 100, whatever changes you make from 100, the percentage increase or decrease will be the same as the absolute difference. So again, you are getting 10. if you want to complicate this problem, keep L and B as the original values of the length and breadth and work it out like we did in the previous problem. It will be a bit too long. So never go for variable method. Choose convenient numbers to make it as short as possible, as I've done here. Now the fourth problem is A spends 20% of his monthly income on rent, 37.5% of the remaining on food, and 10% of the remaining on education, and the remaining he saves. If he saves rupees 45,000 a month, how much is his monthly income? I'll show you a couple of different approaches to the problem, and you can choose whatever you think is better and shorter. Method 1. Finally, you're finding monthly income. This is an absolute number. The question is not about finding a percentage like we did in the previous cases. So let me choose the monthly income as 100x. Let's begin here. He spends 20% of his monthly income on rent. So how much does he spend on rent? 20x. Because, see, this is 20% of 100x. You get 20x. So the remaining will be 100x minus 20x, which is 80x. We're finding the remaining amount because he is not spending 37.5% of his income. He is spending 37.5% of the remaining on food. That's the reason we are finding the remaining amount, 80x. And on food, he spends 37.5% of 80x. So in this context, let me tell you something. 37.5% is a number that you see in percentage quite often. In fact, there are a few other numbers also. I'll take you through that. See, 25%, 50%, 75%, 100%. Look at this. 37.5% is exactly in the middle of this. Similarly, 62.5% exactly in the middle, 87.5% in the middle of 75 and 100. Now 25% is 1/4. Instead I'm writing 2/8. 2/8 is same as 1/4. And 50%, we know that it is 1 divided by 2. Instead let me write 4 divided by 8. This is same as 1/2. Similarly, 75%, 3/4, but let me write it as 6 divided by 8. Now, 37.5% lies exactly in the middle of 20 and 50. So this will be 3/8. So instead of finding 37.5%, let's find out 3/8 of the number. Similarly, 62.5 exactly in the middle of these two. So this will be 5/8, and this will be, using the same reasoning, 7/8. These are certain numbers you keep coming across in percentage, especially in data interpretation. It's good to memorize these figures. So here you're getting that 37.5%. So how do you find out 37.5%? That is 3/8 of 80x. It'll go like this, and you get 30x. And again, you go to the remaining, because 10% of the remaining they say here. So remaining will be what? 80x minus 30x, which is 50x. Let me begin here. That remaining, I'm writing here 50x. Now there is one more expenditure, which is 10% on education. You please refer back to the question. Education, he spends 10% of this. 50x. This on simplification, 5x, and the remaining again. 50x minus 5x, 45x. So this is what he saves. And his saving is given in the problem as a 45,000 rupees. So 45x may be equated to 45,000. You get a simple equation, and you can easily solve for x. See, 45,000 divided by 45, which is 1000. And what is the question about? Finding the monthly income of this person, which we had assumed to be 100x. Can you see that? So x you have found to be 1000. Let's substitute that here. So 100x will be 100 multiplied by 1000. This is 1 lakh. And this is the final answer. This is the monthly income of the person A. This is the first approach. You can cut short a couple of steps here and there. If you're good with the calculation, you don't need to write these things in detail. You can just write 100x, remaining 80x, then work it out on the margin, you will get 50x. You can remove a lot of steps, but to make it clearer, I'm being so elaborate. Second method, let me choose x as the monthly income. See, here x has a different meaning. Their x income was 100x, here it is just x. So don't get confused. If you are able to find out the value of x using the data given in the problem, there ends the matter. That would be his monthly income. If x is the monthly income, and if you are spending 20%, the remaining will be 80%. Can you see that? I'm avoiding a few steps here. Since I have done it so elaborately, I hope you will be able to follow this. X is the monthly income. 20% he spends on rent. So the remaining amount will be 80%. So this is what he has after spending on food. And the second item, they say 37.5% he spends on food. And what will be the remaining? 37.5% spend means the remaining will be 62.5%. See, 100 minus 37.5%, which is 62.5. That's how written this number here. So this is the remaining amount he has after spending on rent and food. Now there is one more item, which is education, for which he spends 10%. If you are spending 10%, the remaining will be 90% of whatever you had. So finally, you have removed all the expenditures in these three percentages and you got the final amount he is left with, which the problem says he saves. So this is his savings, and the savings is given to be 45,000. So you can easily equate this to this. Simplify, cancel this, you will get X, and that would be his monthly income. So, okay, I'll cut it. 4 divided by 5. 62.5%. I have already shown that that is 5 divided by 8. Even if you remove the common factors, you will get 5 divided by 8. I'm straight away writing that. These two will go. 4 will go in 8. Twice. 2 will go 45 times. Let me write one more step. Everything gone here. 45 divided by 100 equals 45,000. So x equals, see, 45 will go here. 1000, 100 taken to the other side, 1000 multiplied by 100, that is 1 lakh. See, x had a different meaning in the previous method, but in this method, x is assumed to denote monthly income. So straight away, this is the answer, monthly income. I'll show you one more method. In this method, we will assume the income of the person as 100. See, this is what is to be found out, and we are choosing it as 100 to begin with. Later, we will do an adjustment using proportionate idea and get the correct income. So, this is taken to be his income. Now, 20% he spends on rent. So, the remaining will be 80 rupees. If income is 100 rupees, 20% spent on rent or whatever, the remaining will be 80. And again, 37.5% is spends on food. So the remaining will be 62.5%. See, I have already shown you this. This is the percentage spent on the second item. So the remaining amount will be 100 minus this, and that's equal to 62.5. That's what I have written here. And let me simplify this. 80, as I have already shown you, this is 5 divided by 8. On simplifying, you get 50. So 50 is the remaining amount. And then what does he do? 10% he spends on education. That works out to 5. So the remaining amount will be 45. Can you see that? And this he saves. This is his savings and this is his income as per the assumption. So when he had an income of 100 rupees, the savings works out to 45 rupees. Actual savings is not 45. Actual savings is 45,000, which is 1,000 times this. Obviously, income will be by the same number of times, 1,000 times. And that's equal to 1 lakh. I've shown you a couple of different methods. Try to understand all the different approaches and you choose the one you like. Here I have dealt with a few simple problems based on the basic concepts of percentage. In the next video, I'll be taking up a few harder problems from percentage. So please hit the bell icon so as not to miss out the next video. By the way, if you found the video useful, please like, share and subscribe to my channel. If you want me to solve any particular problem from percentage that you find confusing, please note it in the comment section. I'll certainly address that. Thanks for watching and see you in the next video.